Okay, so as in the last video, we have solved exercise 1.3 from the federal book. Alright, in today's video, we are going to solve self-check exercise 1.4. As you can see, that's visible on the screen, right? Self-check exercise 1.4. There we have two parts, right? Initially, in the first part, we have two subparts, and in the second part, we have again two subparts. We are going to start the first part of part number 1, right? Let's read the part number 1 first. Zinc and sulfur react to form zinc sulfide. Means we have two reactants here, which are zinc and sulfur, which are reacting to form the zinc sulfide, right? According to the balanced chemical equation, and we have balanced chemical equation given in the question, right? So zinc plus sulfur gives us zinc sulfide. Now they have given us the mass of zinc, they have given us the mass of sulfur as well. Now what we need to determine, we need to solve these two parts, right? They have given us 6 gram of zinc and 4 gram of sulfur. Wait, let me highlight this. 6 gram of zinc, 4 gram of sulfur, right? And they are asking about the limiting reactant. What would be the limiting reactant would be from these both zinc and sulfur? What would be the limiting reactant, right? So let's check that. Limiting reactant means basically the one because of that reactant our reaction gets stopped, right? That is basically known as limiting reactant, right? So let's find the limiting reactant. To find the limiting reactant is very easy. What we need to do, we need to divide the number of moles by the stoichiometry coefficient, right? So initially we need to find the number of mole, but before going to find the number of moles, let me write here limiting reactant formula, right? Limiting reactant formula, and that is basically equal to number of moles divided by the stoichiometry coefficient. Stoichiometry coefficient, right? Coefficient. Now stoichiometry coefficient, that would be provided in the question, right? Here you can see we have already given the stoichiometry coefficient in the equation. There is nothing means there is 1, and that is equal to stoichiometry coefficient. With sulfur we have nothing, not any coefficient, means there is 1, so that 1 is basically a stoichiometry coefficient. So stoichiometry coefficient is already given in the equation, right? What we need to find now, we need to find the number of moles so that we can divide those number of moles by the stoichiometry coefficient, and we should get then the limiting reactant, right? So initially we need to find the number of mole. For zinc, they have given us the mass of 6 gram, right? As you can see, 6 gram. So mass given is basically 6 gram, right? And molar mass of zinc is 65.38 gram, right? Now we know the formula. What is the formula for finding the number of mole? Mole is equal to given mass per molar mass, right? Given mass per molar mass. Given mass they have already given us in the question, and it is 6 gram. Molar mass of zinc we know that 65.38 gram. When we going to divide this, we are going to get 0.0917 moles, right? Moles. But this is the number of moles we have got of zinc. Now we need to find the number of moles of the sulfur, right? Now we are going to find the number of mole of the sulfur. The given mass they have given in the question, that is equal to 4 gram, and that is basically given mass, right? And molar mass of sulfur is 32 gram. What's the formula for finding the number of mole? Mole is equal to given mass per molar mass, right? So given mass 4 gram and molar mass 32 gram. When we're going to divide this, what we're going to get is 0.125 mole, right? Now we know the formula for finding the limiting reactant, right? We need to divide the number of mole by the stoichiometry coefficient. We know that what is the stoichiometry coefficient for zinc? The stoichiometry coefficient for zinc is 1, right? And that too, the stoichiometry coefficient, coefficient for sulfur is 1 as well. Now we need to divide this mole by the stoichiometry coefficient, then we'll go and find the limiting reactant. So number of mole is equal to 0.0917 divided by 1. We have got 0.0917, right? And here number of mole is equal to 125 divided by stoichiometry coefficient 1, and here we'll also get 0.125, right? So now see, what is the limiting reactant here? Is 0.0917 is the less number or 0.125 is the less number? Of course, we know that 0.0917 is the less number. So here we have got that zinc is the limiting reactant, right? Because of this number, we have got that zinc is the limiting reactant. This is how we find the limiting reactant of any equation. Limiting reactant means because of the zinc, our reaction gets stopped here. Because of the zinc, right? Because zinc is the limiting reactant in the equation. So we have done our first part, right? Part number A, we have done that. You can see the answer to here. Zinc is the limiting reactant. The whole is consumed, right? Now we need to find the mass of the zinc sulfide produced. Now we need to find the mass of it, right? Mass of it. So the finding the mass of it, we know the molar mass of it, right? Initially we need to find the moles of it, right? So number of moles we can get from here, right? So the zinc mole we calculated, and that was basically equal to 0.0912, right? So if there is 1 mole of it, so it will gonna produce 0.0912 moles of it as well, right? Means we know the moles of zinc sulfide and we know the molar mass of zinc sulfide as well. Molar mass of zinc sulfide is equal to 97.38, right? Now we know the formula, right? Let's put the formula for finding the mass of the zinc sulfide. Mass of zinc sulfide produced, right? Initially, let's write the general formula. Number of mole is equal to given mass per molar mass, right? We know number of moles, we know molar mass, we are finding the given mass, right? So here molar mass is dividing, whenever we go there it will be multiplied. So given mass is equal to number of moles into molar mass. Number of moles we already know, right? That is equal to 0.0912, and mass of zinc sulfide that we know as well, and that is equal to 97.38, right? When we multiply these both, what we get is 8.929 gram. So this is the mass of the zinc sulfide which will be produced by the combination or by the reactants of zinc and sulfur, as you can see here, 8.95, right? So we have done our second part as well. In the next video, we're gonna continue this question since our second part of this uh, self-check exercise 1.4 is remaining. So we're gonna continue that in the next video. This was all for today.